Good evening. I'm here to share my discussion topic one. For topic two, the question was many real world data sets exhibit outliers or extreme values, discuss the potential impact of those outliers on measures of central tendency and variability, and propose at least two methods for identifying and handling outliers in data analysis. And then there's examples of Python in here to show how we can handle those. So outliers are extreme values. They're values that lie on the outsides of our data set, like in the normal distribution, like you see the little like bell chart looking things. Those are going to be the ones that are on the extreme ends. So in terms of mean, outliers can skew the mean so that it's not representative of most of the data. For the median, outliers are less, it's the median is less affected by that. So generally people tend to use median a lot when they're dealing with extreme data sets. And the mode is unaffected by outliers because it just represents the most frequent value. So for variance and standard deviation, it's sensitive to outliers because they square the differences from the mean, which exaggerates the impact of those extreme values. So to use Python to look at these, we can, first we have to pull in our data set and have a look at our data set. I didn't actually have any outliers on this, so I made one. It's a 7-foot tall dog. So, no, 6 feet tall. So you'll see him get pulled in down here. So we're pulling in our data. I had to do a little math because it doesn't have one average height for the dog breed. So I had to come up with the average height for the dog breed. And then obviously a 6-foot tall dog is way out of the normal. So that one's going to get pulled out so it doesn't mess with our data. So I used IQR for this one, where it looks at everything between the 25th and 75th percentiles, and basically like anything outside of that just kind of gets booted because it's just too extreme. I also use the z-score method. Oh, there's an empty one. So to identify the z-scores, you can use this formula here. You can literally just do stats z-score and it will give you one. So I love Python. So again, we have this 6-foot tall dog. I cleaned the data out. I printed it here so that I could see that the dog was gone. And it was. So after I cleaned the data, I put it in, before I cleaned the data, I wanted to show you guys the plot of what the outlier does to it. So here's our outlier. So it's really squished up our data here. So to make it a more clear looking plot, I'm so glad that we have charts like this that show us where our outliers are so that we, if we forget to do this in the right order, it will be like, oh my gosh, there's an outlier. Let's get rid of it. So once we get rid of it, we have this beautiful looking, what's it called? Box plot right here. I used Seaborn for this so that we can see what our average is. So the mean and the median and the standard deviation of this is printed out right here, the central tendency and variability. So the mean or the average weight of our dog breeds is almost 43 pounds, and then the median is 45. So these are the sources that I used. Thanks for tuning in.